Honors Algebra 2, Chapter 4 and 5. This is the last part E. Behaviors of graph and basic solving is the first thing we're going to look at. So we're looking at graphs of polynomials. Polynomials have degree 2, 3, 4. We're going to look at bigger polynomials than just quadratics. We should know our shapes. We've already talked about that, how this is a degree 3, so we know the general shape of this. We should also realize that when you look at this graph, we have the two turning points, which we'll talk about tomorrow, how to find those again. We also have our zeros, or our x-intercepts, which we've also mentioned in the previous chapter. So we have two turning points in this graph. We have 3 zeros, and here we have the negative leading coefficient. So now we're going downwards, left or right, we go down. We still have 2 turning points, one less than degree, and then we have 1, 2, 3 zeros. So these patterns are all holding true. So for this one here, we have a degree 5 with a negative leading coefficient. Negative leading coefficient, degree 5. So you can see it's going downward, left to right. We can look at the end behavior. It's going downward. We have 1, 2, 3, 4 turning points, one less than the degree. Then we have 1, 2, 3, 4 zeros. Now that's less than what we have. So this power of 5 is the most amount of zeros we can have. We could have less than it, but it's the most amount of zeros we can have. And we'll talk about this. This zero right here is a special zero. It's actually called a double root. It actually has 2 zeros there at the same point. So these still hold true for degrees 4. So we have that W shape here going upward because of positive leading coefficient. We have 3 turning points, and we have 4 zeros or roots. And then here, negative going downwards, we have 1, 2, 3, 4 zeros, and we have 3 turning points, and we also have our end behavior. So we've already talked about end behaviors in previous chapters, so I just want to review real fast for this graph here. As x approaching positive infinity, which means right, y is approaching negative infinity, which means going down. And as x approaches negative infinity, which means left, y is still approaching negative infinity, going down, because we're going down for both left and right. And so we can write that other way. This is the same meaning. So we've already solved quadratics here, where we set each factor equal to 0, and then we can solve that. So here x is -6, and here x is 2. We can find our solutions from the factors. So these are called solutions, zeros, roots, x-intercepts. These are also names that mean the same thing. Roots, x-intercepts, zero solutions. And so for here, for the graph, where does that occur on the graph? We already talked about that. It's the x-intercepts. So we should see that there should be a spot here and here at 2 and -6 where the parabola crosses it. We know it's a parabola because it's x times x squared. And so we're kind of trying to tie a lot of our graphing and things together. So for this one here, first thing we have is we have 3 x's being multiplied together. So I know the degree here is x cubed. The numbers in front are all 1, 1, and 1. So I know my leading coefficient is 1 or positive. So right there I have the shape. I know it's going to be a positive, and it's going to do something like this. So looking at our behaviors of graphs, we should know the shape of it. Now what are our x-intercepts, our roots? They're -9, 3, and -5. And so we can get a picture of what the graph's going to look like just by looking at the factors. And so the graph here, we have 0 at -9, -5, and 3. And then we have this behavior shape. Now the only other point that would be really quick and easy to find would be the y-intercept. The y-intercept is found by multiplying all the constants together. So the 9, -3, and 5 would give us this value. So you're at -135. So these scales are not going by ones. So we can do the same thing here. We can actually find our zeros. We can know the shape, x to the 4th, because we have 1, 2, 3, 4 x's. The leading coefficient is still 1. So I know the general shape. It's got the w going upwards. And so then we can actually then graph that. And check that. Same thing here, x cubed, and then we have a leading coefficient of 1, and our zeros are 2, 2, and 5. Now this one's a little different because these two factors are the same exact thing, and so they produce two of the same x-intercepts. Now remember the shape of this. X cubed has this shape. So what occurs at 2 when we graph that? Notice at 2, that is that relative extreme, that max or minimum. When you have a double root or a double zero, that is a max or min value in the graph. So it's kind of a way of seeing more of the graph, what's happening. So we can look at the factors and then we can actually sketch it. So we can actually plot -7, there should be a point. -4, there should be an x-intercept. And then 1 and 2, they're also x-intercepts. Because it's x to the 4th, we have 4 x's here, x to the 4th. All of their coefficients are 1. So I know I'm going to have a W shape, and it's going to go through these points. So I just sketch the W shape through those points, and that's okay sketch. Is it very accurate? Probably not really, but we have the zeros. We could label the point right here if we wanted to as the 7 times 4, 28 times -1, -28 times -2, so we have positive 56 is this y-intercept here. We have that double root, so our x-intercepts are 3 and -1, so we plot those. Some students think it's got to be a parabola, so it just only hits the x-axis twice, but this is really x cubed. And x cubes have this shape with a positive leading coefficient. So our double root is at that -1 value, so this is a double root. So I'm going to approach that turning point, and I'm going to turn at that point and then cross over here. So this is a relative extreme at -1. So here is your problem I want you to do for your video problem. Be careful, kind of a tip of this negative here. Think of what that might do to your graph, and then try sketching one. So we can go backwards here. We can take the x-intercepts and write those down. So this would be, assuming we're by ones, 1, 2, 3, -3, -2, 0, 2, and 3. So we can actually identify the zeros. Here we'd have -2, it's a extreme, it's a relative min, so we have a double root, so -2 and another -2, and then we have 1 and 2. For this one, 1, 2, 3, 4, 5, so we have -5, -1, and 2 are our zeros, or our x-intercepts. We can take these and we can put them into factored form. So this 0, -3, comes from the factor of x plus 3. So we can write all these as factors. So x plus 2. 0 we can just write as x. And then 2 would be x minus 2. And then 3 is x minus 3. So these are the factors. We can do the same thing for these problems. For this one I have a double root, which is x plus 2. But instead of repeating it, I'm just going to make it squared. And we have x minus 1 and x minus 2. Now I'm not going to do the third one. But we could take the third one and put it in a standard form, so you can actually write it in factored form, and then you can actually do all the foiling and multiplying to put it back in standard form. So that's it, a 5-8. 5-5 is looking at dividing. We're going to split this into 2 days. Tonight we're looking at just synthetic dividing. It's one method of dividing. It's one most students tend to prefer. It's usually less complicated. So we synthetic divide, it's kind of a different setup. You look at the coefficients of each of the terms, or the constant. And so we have 1, 2, and -15. And what we're doing is we're trying to see how many x minus 3's fit into this trinomial. So I'm looking at these, just the numbers. I'm going to have those numbers. I'm going to draw this little board. And on the other side here, I put the actual 0. X minus 3 is the factor. 3 is the 0 or root. So the process for this is that we actually drop that first number 1. So we bring that 1 down. Then we're going to multiply 3 times 1 and write it below the next number. So that's 3. We're then going to add those numbers, and we get 5. Then we're going to repeat that process. Multiply here, right below the next number, 15. So we're going to add there, and we get 0. I box this number in. This last number is really our remainder. So that's our remainder is 0. And if you work backwards, that's our remainder. 5 is our constant. 1 is the coefficient of x. So the answer here would actually be x plus 5, which makes sense because we take that original problem and we can factor this. It factors to x minus 3 and x plus 5. So what we've done is we've used synthetic division to find the other factor of that trinomial. So synthetic division is a way of dividing the polynomial by a binomial. Now synthetic division only works if you're dividing by a binomial that has a leading coefficient of 1 there. So for this one, I would have a 4 on the outside. My coefficients are 1x cubed minus 8x squared, 4x, and 48. So the process, drop the 1, multiply 4. We add there, we get negative 4. Multiply again, negative 16. Add, we get negative 12. Multiply again, negative 48. Add, we get 0. Nice, no remainder, which means it divides evenly. So then our answer here, negative 12 again is our constant, negative 4 is the x, 1 is the x squared. So we're going to write that as x squared minus 4x minus 12 is the trinomial solution when we divide. Down here, we're gonna divide again. We have negative 3 on the outside. You have to use the 0, not the factor, the 0. Now write the leading coefficients. If we don't have a term, let's say there's no x term, I would still need to put a 0 for the term. You kind of have to hold that place value, hold that term value. All these examples have all the terms from the biggest degree to the constant, but if you're missing a term, you need to include a 0. So same process, drop the first number, 1, multiply, add. So we have negative 6, multiply, 18, add, negative or positive 11, multiply, negative 33, add, so this one does not divide evenly, so we have a remainder here of negative 20. So when that occurs, you still have an answer, it just doesn't divide evenly. So we still have x squared minus 6x plus 11 minus, because we have minus right here, minus 27, and then we were still dividing. We were dividing by x plus 3, so this can be divided by x plus 3. It doesn't divide evenly, so that's the remainder divided by our divisor, and so that's going to be the result. So second homework problem here, try it using synthetic division to divide this polynomial by this, and then have a good night.